the first thing we're doing today is a review. So based off of the factored equation that I've written here on the board, we want to find the general form of this equation, and we want to find the vertex of this equation. So we are going to take a moment, and we are going to do that first. From here, we found the general form, we found the vertex, right? So let's see. How do you see number of rows? 1, 2, 3, 4, and so on? All right. Can I get someone from row number 2 to tell me how they distributed these two components? Yes.
I went x times x, which is x squared, and I got, it turns out being 4x, because, and minus 45.
All right. So distributing this out, we got x squared plus 4x minus 45. All right. And then if we distribute our negative 3 in, we will end up with negative 3x squared minus 12x plus 135. All right. So this right here is our general form. And now we need to find the vertex. Can someone tell me, not what the vertex is, but can someone tell me how they might go about finding the vertex? Yes. All right. So you used the factored form up here, and you used that midpoint to find what the axis of symmetry was first. What is the axis of symmetry that you got? All right, so you got x is equal to 2. Right. Did anybody else get x equals 2? Or did we arrive at something else? I don't actually know, but you got negative 2? All right, so it could be positive or negative 2. Did you also get negative 2? Okay, so we got a negative 2. It was close, right? We just dropped a negative somewhere. All right, so we did this by using that midpoint, right? And so if we look at over here, that was using the roots, right? We used the roots. And so our roots here are 5 and negative 9. So you just did 5 plus negative 9 over 2 and got negative 2. So midpoint is one way that we can do it. Did anybody else do it a different way? Or know of a different way? Yes. So if you look at the general form here, the axis of symmetry formula was x is equal to negative b over 2a. What would our b be? All right. So this right here is our b. Negative 3 is our a. All right. And then from here, you also got negative 2. All right. From negative 2, we have that x value. So how can we find the vertex with just an x value? Yeah, we can just plug the x in. Doesn't matter if we use this the factored form or if we use the general form. It doesn't matter. You can plug it into either one. All right. So what was the vertex if we put it into, I want to put it into this top equation just because I think it might be a bit simpler for us. So if we said negative 3 times negative 2 minus 5 times negative 2 plus 9, if we factor this out, we will get, this is a negative 7, this is a 7, so this is equal to negative 3 times negative 49. Yeah? And then that looks like it'll be positive, was it 147? 147. All right, so then our vertex we know is negative 2, 147. Okay? All right, next thing that we want to do, remember our Desmos graphs? We did Desmos 2 days ago, and then I showed you guys an example. I want to show you another example today, because I really like Desmos. But this one is going to be a little bit different. I don't want you to find just an equation. I want you to find what happens if our function has an x equal to 5. What does our function equal? In other words, what is y equal to if x is 5 for this graph? All right? So I'll give you a few moments to do that. And let me know if I need to kind of blow up these numbers because you can't see them from the back. All right? I'll pause while we do so. In order to find the value for y here, what do we first have to do? Find some formula, right? So what formula would you suggest? Would you suggest vertex, factored, or general? Vertex, all right. So our vertex here is 3, 4. So can someone tell me what they wrote for their vertex formula? Yes. All right. Who agrees? Or who has something that they need to change? What do you think we need to change? I tricked you guys. I'm sorry. Right here we have a vertex. If you go over 1 square and you go up 1 square, you're not going to arrive at the next point where it intersected. You have to go up 2, which means that our graph here was stretched by a factor of 2. All right? So we have our vertex now from our vertex. If you forgot about this too, this is the hardest part about looking at these graphs and making a formula from these graphs, is just this stretching and shrinking component, all right? So from here, we still want to find what happens when x is 5, right? So all we have to do is just put 5 into x, and if we do this and we solve it out, that means that we have a 2 times a 2 squared plus 4. Yes? Yeah? All right, so if we have that, then what is our final answer? Who agrees with 12? All right, the majority has spoken. So if we have a function with an x of 5, then our function's value is going to be 12. Right? Yes, question. That is this 2 right here. This one right here. So if we go back up to our graph right here, from our vertex, if we head over 1 in the horizontal direction, then we need to count how many up we go vertically until we connect back with our graph, with our parabola. Because this will show us how much we are shrinking or how much we are stretching. So if we had a parabola instead that looked like this, instead, here's our vertex right here. We go over 1, and then we need to count how many up we go, right? So we just go up 1. This would have, this coefficient right here would just be a 1. But because what we are looking at is this parabola right here, we go over 1 and we have to go up 2 before we reach the rest of the parabola, then we know that it stretches by a factor of 2, right? Okay. So what we want to do next is, if you looked at what today's unit is, it was just going from the general form to factored form. Have we done that before? Yes. I don't think we need to do it again. I'm just going to give us one slightly tricky factored form one. All right? Just one. And see if you can factor this one on your own. All right? I believe this is a negative 2x squared minus 10x. All right? So take a few seconds. Try and factor this one out. We'll get into trickier factoring tomorrow when we have more time. But for now, try and figure this one out. All right? I'll give you a few moments to do so. Just a little bit of a hint while you are factoring this. What is one thing that we can definitely factor out of each of these terms? A 2. So if we factor out a 2, we'll have x squared minus 10x plus 12. But I heard something else. A negative 2. So if you have a negative 2, then this becomes negative, this is positive, and this becomes negative. Isn't it so much easier to factor if you don't have a negative x squared? Yes. All right. I didn't factor those, did I? Good catch. All right. Let me just factor those then. So that would be 5x and 6. And then I got to switch these signs around. Does that look factored now? All right. Thanks for catching me on that. All right. From there, do we need any more time with factoring this out, or do we think we got it? We got it? All right. From here, the reason why I think that this one is hard, what are the factors of 6 that we could use? There's 2 and 3, or there's 1 and 6, right? For this negative 6 here, do we have to multiply or add to get that 6? We need to multiply. So this right here, we need to multiply to get this. And this right here, we need to add to get this. All right? So if we multiply 2 times 3, can we also add 2 plus 3 to get 5? Yes. If we have 1 times 6, and you do something like negative 6 plus 1, can you still get some kind of factor of 5? You'll get a negative 5, right? So both ways you can get some kind of 5, which is why I think that this one's kind of difficult. But you guys probably got it. So in here, which factor did we use? 2 or 3 and 1 and 6? 1 and 6? All right, so we have a 1, we have a 6. If we have a negative sign right here, does this mean that we need a positive and a negative, a positive and a positive, or a negative and a negative? We need 1 positive, 1 negative. All right, so then which one is positive, which one's negative? 6 is positive, 1 is negative. All right, and then we get, that looks good, and we have just factored, all right? So from this is all basically the material that you'll need for your homework tonight. Can you quickly get out the homework? I'm going to tell you which ones you can skip. And then after that, I'm going to talk with you a little bit about the drone lab. All right? Remember that lab that we started an age ago? Yeah. All right? We will talk about that once we have the homework questions selected. All right? For these, there are 18 questions on this homework. I'm going to make you do half of them. Okay? Half. So I'm going to read off the ones that you should not do. All right? The ones that you should put an X through because we're not doing those. All right? It's close, but not quite. All right. So does everyone have their homework up? All right. If you don't and you just can't access it right now, just pull up your notability document and just write down the ones that you should not do. All right? The ones that you should put an X through right now is 1, 3, and 5. I will also repeat it at the end of class. All right? 1, 3, and 5, put an X through those. We're good? Okay, 1, 3, and 5, put an X through them. 10, 11, and 12, put an X through them. 13, 15, 16, and 17. Put X's through all of those. All of 17. All right? You will have to do one with multiple steps, and that is number 18. But I think that one will help you. All right? So the ones that you are not doing, 1, 3, 5, 10, 11, 12, 13, 15, 16, and 17. All right? Okay, now I want to switch gears. So once you've had those crossed out, either pull out your drone lab if you have it, or pull up a notability document. Right. If you have lost your drone lab information, then what you need to do is you need to find the numbers from somebody else in this class. You have those numbers. And the worksheet is on Schoology, so you can just reprint out that page. All right? I'll give you a few seconds while you guys are getting that out. Before, we have talked about how to calculate the components that we need to solve this lab, correct? We have talked about it. If you have not done the calculations yet, I would recommend doing the calculations sometime this weekend, so that if you get stuck, you can come in during Monday morning or maths. It was originally due tomorrow, and then we realized that we had never told you guys any information about what you needed to do. So it is due next Wednesday, all right? That means your test is next Tuesday. Your lab report is due next Wednesday. And so the reason why we didn't want to make it due tomorrow is because we have said nothing about a lab report, and you've never done a lab report in this class. Also, it's a math class. Like, who does lab reports in math class? We do, all right? It's good practice for your science classes, and it's good practice for communication overall. All right? So, for the lab report, I want to go over the components that we need for our lab report. All right? This lab report, fun fact, if you ever take a science class in, like, college, if you think all the way to college in the future, if you ever do a lab report in college, it'll be like 10 to 15 pages minimum. All right? The lab report I want you guys to do will be maximum 1 to 1.5 pages. And the only reason why it is that long is because you will be including your calculations, maximum, all right? Minimum, as little as you need to do to address all of the components that we'll be talking about. All right? Okay. A lot of that is going to be your calculations, which probably take up like half a page, and a drawing, all right? Which will probably take up maybe not half a page, because that would make one page, all right? So what we want in our lab report, the first thing that we want is a procedure, or is a purpose statement, correct? A purpose statement. Basically, what are we trying to do? All right, so, for example, what is one of the things that we did with this drone lab? We flew a drone, right? What direction did the drone fly? Horizontally or vertically? Horizontally. So one of the purposes was calculate the speed of our drone in the horizontal direction in some particular units, right? And then we had two different components of horizontal motion, right? We had the running start and the stop start. And then there was one other thing that we did while we were outside. What was the other thing we did besides flying the drone? There was the rotations per minute, yes. And there was the pacing. The pacing is also part of a purpose, all right? So you have pacing as part of your purpose, you have the horizontal motion, and you have something to do with the RPM of the propellers, all right? Those all need to go into your purpose statement. Your purpose statement should be like 1-2 sentences, all right? It's not a paragraph. just a few sentences. The second thing I would like is some kind of sketch. Sketch out what you did, sketch out what the drone did. That's basically it, right? Sketch out what the propeller did. Just sketches of what happened. All right? The third thing is a procedure. This is the first thing we did. This is the second thing we did. All right? Make sure if you're talking about distances, include what that distance is specifically. We paced 10 yards, except we wanted in feet, right? 30 feet? So we paced 30 feet. It took us this many steps to get 30 feet. All right? This does not have to be in sentences. This can be bullet points or a numbered list. All right? After that is just the calculations. So for example, if you're writing this on a notability doc and you just want to take a snapshot of your calculations because you did it with pencil and paper, you can do that. If you're doing this on a Word document, you can still just snap a picture and include it on your Word document. All right? These are just your calculations. Make sure with your calculations that you box your answers. All right? Your answers need to be boxed. And then the last thing that we want is a conclusion. Based off of your calculations and based off of the purposes that you had, what were your results? And this should be a few sentences. So this is, what did you find? And then the last thing that I would like you to include in this conclusion is one math concept that you learned, you improved on, or that you used a lot during this lab. All right? One math concept. All right? That's all you need for the lab report. It's just a few sentences, a few bullets, a picture, and your calculations. All right? If you have any questions, either on calculations, on what more do I need in my lab report, we are free Monday morning, and we are free during mass. All right? So you may come in one of those 2 times. Okay? So from there, we have maybe like 5 minutes. If you would like to start your homework, you may. If not, you may relax a little bit. All right? This is like halfway through the school day, which is kind of weird. All right? All right, and that is all for today.